Ionic bonding happens between metals and non-metals. Ionic bonding involves the transfer of electrons. Metals lose electrons. Another way of saying that is metals form positive ions. Great. Non-metals gain electrons. Another way of saying that is that non-metals form negative ions. Keyword that we've got there that's come up is ion. Okay, an ion has a charge. Okay, so what makes an ion and not an atom? Ions have a charge. An example of an ionic compound that would have ionic bonding would be sodium chloride. Na is sodium, Cl is chlorine. Sodium is the metal. It will lose electrons. Chlorine is the non-metal. It will gain electrons. Okay, the electron is transferred from the sodium to the chlorine. I have another video that zooms into this in more detail. I will link in the description. But for now, let's carry on talking about ionic bonding and ionic compounds. So the sodium is a metal, so will form positive ions. The chlorine is a non-metal, so will form negative ions. This is what the structure will look like. Well, this is how we represent what the structure is, will look like. Imagine it's a negative ion there. This regular repeating pattern is called a giant ionic lattice. Okay, really important that you remember this. It's a giant ionic lattice. Positive, negative, positive, negative, positive, negative, and so on. In an ionic compound, in a giant ionic lattice, these ions can't move. Okay, that's really, really important. Those ions cannot move. Because the ions cannot move, an ionic compound, when it's solid, can't conduct electricity. Key idea there. Solid ionic compounds cannot conduct electricity. Really important idea. You definitely need to remember that. Now, I've mentioned here when solid. Let's circle back a bit and talk about the melting and boiling points. There's a space for that. And boiling points of ionic compounds. Let's circle back to talk about this. So, in between the positive and negative ions, square brackets means it's an ion. That one is going to have a 1 positive charge. That one is going to have a 1 negative charge. In between these oppositely charged ions, remember, oppositely charged things attract, there are going to be strong forces that I'm representing here with squiggly lines. Okay? These are strong electrostatic forces of attraction. Strong electrostatic forces of attraction. These bonds are strong, they take a lot of energy to break, and therefore ionic compounds have high melting and boiling points. So let's jump back to here. So we said when solid, when the ions are locked in place, when the ions can't move in this giant ionic lattice, the ionic compounds cannot conduct electricity. But when liquid, and when we talk about ionic compounds, we tend not to say liquid, we tend to say molten. It means the same thing. The ions can move. Now, let's think about what this might mean for the conductivity. As the ions can move, liquid ionic compounds can conduct electricity. Can conduct electricity. In fact, it's not just when liquid or molten, it's also when dissolved. It's also when dissolved. And another way of saying that is aqueous. A-Q-U-E-O-U-S. Aqueous. So when liquid, molten, dissolved, or aqueous. A typical exam question you might get on this topic would be something like, explain why sodium chloride has a high melting point. That's what we spoke about there. Another question that you might get is, explain why, when solid, sodium chloride cannot conduct electricity. That's all for today. Any comments, please drop them in the comment section.